Hello and welcome to this video brought to you by Smart Edu Hub Mumbai. In today's video, I shall explain to you how to find the number of valence electrons by looking at the periodic table. Now for this you need to know the group numbers. Look at the first group, that is the group 1. And now I'm going to highlight the elements of the group 1, namely lithium, sodium, potassium, rubidium, cesium and francium. Now don't ask me why I did not highlight hydrogen. In my previous videos, I've already mentioned that hydrogen does not have properties which resemble the elements of group 1. Therefore, it is not supposed to be present in group 1. Rather, it is not having properties similar to any other element, and therefore it should be placed just randomly somewhere in the middle of the periodic table here. And yes, there are periodic tables which are rightly placing hydrogen just in the center of the table to show that it doesn't belong anywhere. But the one that I've picked up has hydrogen placed in the group 1. Rather, you'll have most of the tables putting hydrogen in the group 1. So, fine. So, the number of valence electrons will also be 1. So, whether it is lithium, sodium, potassium, rubidium, cesium, francium, all of them are going to have just one electron in their outermost orbit. And you know what is the meaning of valence electron? Valence electron is the number of electrons in the outermost orbit. So now let me go to the next group, and that is group 2. So now let me once again highlight the elements of group 2. They are beryllium, magnesium, calcium, strontium, barium and radium. Now once again the same rule applies, that the number of electrons in the outermost shell or the valence shell will be equal to 2, which is again the group number. So that means the group number itself is the representative of the number of valence electrons. Okay. Now one more thing to remember is you are not going to use this same rule for calculating the number of valence electrons for transition elements. Why? Because all these elements will have more than one valency. So we are not going to make use of the same rule for the transition elements. So please ignore this entire thing shaded in green. We are going to ignore these elements shaded in green. Okay, fine. So now what next then? So going back to the counting, we will go to the group 13. Now there is one thing to remember. When you go to group 13 and from group 13 when you go to group 18, in all these groups, remember, it is the number in the units place which is the representative of the number of electrons in the valence shell. That is, here the group number is 13. Excuse me. Here the group number is 13. So in this, 3 is the number of electrons in the valence shell. So when you have the group number, say 14, 4 is the number of electrons in the valence shell. Similarly, for the group 15, 5 is the number of electrons in the valence shell. For the group 16, 6 is the number of electrons in the valence shell. 17, 7 are the number of electrons in the valence shell. And for the group 18, there are 8 valence electrons. So that means it's always a number in the units place which indicates the number of valence electrons for the particular element in that particular group. So this is true for all the elements. Remember, I told you, you are not going to use the same way of calculating the valence electrons. For the ones that are highlighted in green, those are the transition metal elements because they have variable valencies. So ideally, that is how you're going to calculate the number of valence electrons for any element of the periodic table. And then you'll ask me, then how do we know the valence electrons or the charges of the transition metal elements? Well, you'll already be given. You'll be told if it is iron 2, iron 3. Okay, so do not worry about it. So that's all in this video on finding the number of valence electrons by looking at the periodic table. If you like watching my video, please do subscribe to my channel. Thank you.